Plastics are used everywhere in consumer products and automotive applications. Plastic products are low cost to produce, allow for complex shapes, and can be produced repeatedly in high quality, high production volumes. Another reason is that plastics are lightweight with relatively strong materials. Many plastic products that have strong structural requirements are reinforced with glass or carbon fibers. The fibers are very strong and take huge loads. The polymer is very light but weaker, but forms the glue between the fibers. The resulting composite material has the best of both worlds, and is strong, lightweight, and can manufacture complex parts using injection molding. Two important things to understand though. The materials are very strong in the direction of the fibers, but relatively weak perpendicular to the dominant fiber direction. Secondly, the amount of orientation has a huge influence on the mechanical properties. Highly aligned fibers will be very strong in the fiber direction but weak perpendicular to it. Randomly oriented fibers will be much weaker than the highly aligned fibers, but are stronger than the perpendicular to it. So in summary, the material properties are very dependent on the orientation, direction, and the amount of orientation of the fibers. In injection molding, the fiber orientation is depending on how the material flows through the cavity. It will change from location to location and over time. In Moldflow, we can calculate the fiber orientation and mechanical properties as a result of the molding process. In this simple example, we find areas of expanding flow where the orientation of the fibers is predominantly perpendicular to flow direction, other areas more random orientation, and other areas where the orientation is primarily in the flow direction. The same orientation has direct correlation with the mechanical properties. Areas that are highly oriented have a high modulus, other areas with random orientation will have a much lower modulus. The difference in modulus can be very significant, as you can see. On the flip side, areas that have high orientation will have a very low modulus perpendicular to the dominant direction. So even on this very simple example, we saw a huge amount of variation in the mechanical properties as a result of the molding process, which can be simulated by Autodesk Simulation Moldflow. In order to calculate the structural performance of fiber-filled plastic products, the manufacturing process has to be considered in the simulation. There are interfaces available between Moldflow products and the mainstream structural analysis products.